Hello, GM everyone. So the concept for the day 4 is tokens. I have actually written a lot of stuff here that we're going to go through. Tokens is very conceptual thing in Web3 as most transactions go through tokens. ETH is also a token. BTC is also a token. So now let's understand what are tokens and how are they different from USDC. Okay. So tokens, their value is not controlled by any government, any institution, any centralized body in the world. It is just determined by how rare it is and how liquid it is. So these are the two factors that decide why an asset has its value. So first factor is rarity and second factor is liquidity. Rarity means, let's say, gold. Gold has a fixed amount of supply in the world, hence it is very costly. And similarly, liquidity, that how many people are willing to transact in that asset or use that asset as a medium of currency. Okay, now let's go here and let's see what tokens are made up of. So they have these following properties: name, symbol, decimals, transfer. That is, name is name of the token, symbol is the ticker, that is BTC for Bitcoin, ETH for ETH. Decimals means how many decimals does a number should have to be 1. So like if decimal is 4, so 1 and then 4 zeros will make 1 token. And then transfer means sending from one to another. Balance of is we can provide any address and get it, image of the token. And then there is mint and burn. Okay, so there is no governance and hence these tokens can be limited to fixed supply. So these don't support inflation. Okay, a government cannot wake up one day and say, okay, BTC will be priced at this. Whereas in USD, they can actually print more USD, and that's what happened in 2008 and 10. And that's where the whole story started of Web3 and blockchain. Satoshi Nakamoto was a very big fan of this term called free market strategy, where every person has a say over the market and not just the government and big institutions. So this is something called initial supply of a token. So 1 million tokens are released at once and then it is locked forever. There are only 1 million of them out there. There can be decrease in the supply and there can be increase in supply if demand arises and if everyone agrees that there is a need to print more tokens. Okay, so let's get into this. Let's open up a terminal. I was actually halfway through filming this and it was stopped. So let's go. CD 15 days, 15 contracts. Let's remove day 4 here and let's init a new day 4. Get status, get a dot, get commit, check, get push, and get, okay, that's okay. Forge, init day 4. Basically you can give a folder name and the folder will be there. So cursor day 4. Now let's reload the window and let's see what tokens we have, what can we include in this. Okay, now src test and script have all these counter files which we are going to delete, and simple delete here, and let's make a token.sol here. Now I hope that we are familiar with what each folder does and what each folder are made up of, and also we are very familiar with how license identifier, like the main जो भी fundamentals of writing a contract होते हैं, I think we are through that. So we need to just focus on core logic of things. Okay, now I forgot to explain what is an ERC20 that I have written here. Let me go through it. ERC20. So basically Ethereum is a blockchain that keeps evolving. Now this evolution has many features added, many features removed. Each feature is called an EIP. Basically EIP in Ethereum, that is stands for Ethereum Improvement Proposals. And when they are proposed, let's say I want to propose an idea of having tokens, so they are EIP20, and whenever they are actually resolved and accepted by everyone, they are converted into ERC20. That is Ethereum, what does it stand for? What is ERC? ERC is in Ethereum. Yeah, we need to have the keyword Ethereum request for comment. So that is the added feature in ERC. Okay, so that's what we have here, and let's get right into it. Now there is a library called OpenZeppelin contracts. Basically they have a lot of contracts given in one, so that you can directly use those contracts, implement on top of them, basically abstract classes and abstract contracts like this, and then you can write your own implementation if you have, and you can use the default implementation if you do not have any. Okay, so let's use the command of forge install, and let's go for that, and let's see no commit. Okay, that's cool. What happened here? Could not determine the root folder, no such file or directory. Okay, what happened here? Slash no commit. Could not determine, consider reporting to okay, this could be an error that I was basically stuck at. Let's remove rmrf and let's do day 4 for this, and let's get a dot, get commit, whatever, delete, and get push. Let's create a new directory called mkdir day 4. Let's keep those in capital to resolve that. cdta by 4, and let's forge into this, and let's see if we can do that. No commit. Yeah, now it is installed, right? So this is what we are here for, and I just debugged an error in front of you. So that's how things go when you're writing code in Web3. You have to be quick and think on your feet that what could the error be. So let's go for token.solve. Now spdx license identifier mit. Let's keep this version at 20 and import ERC20.sol. This is the ERC implementation. Now why does this show this red squiggly? Because the contracts are in lib and not directly at any thing. So we need to add this remapping. Okay, so where do we add the remapping to? We add it to foundry.toml, which is the config file from where everything is made. Remappings actually. Yeah, and this will be resolved now. Or if I had to reload the window, this is resolved now. Place the mic here. And let's delete this, and yes, let's get right into it. On track token is token, or say ERC20. Now let's think of what an ERC20 needs. Okay, so ERC20 would need something that is called a constructor. So let's go here, let's go to contracts, let's go to token, let's go to ERC20, and let's go to ERC20. Okay, now the constructor needs a memory name and a memory symbol. Okay, so for now, let's hard code them, and later we can actually have a constructor that calls them. So let's say string memory name, private name is equal to name is equal to my token, and similarly symbol mtk, and let's do that, and then we can call the constructor. So constructor name and symbol, and the message dot sender. Oh, why is this a red squiggly here? Expect this is just, look, I need a new extension for Solidity. The errors get resolved very late. Okay, now what function does a token need? Okay, so it has an, let's see the implementation here. Okay, it has a total supply, so how much of the tokens are totally supplied here. Then it has a balance of, it has a transfer, it has an allowance. So basically everything that you need a coin to be able to do. Then let's go back here. String memory name, and let's go for this, and let's go for this. String public I'm very confused at the order of these identifiers and the storage tokens. So let's think about them for a second. Or best, what we can do is let it be. Let's go for this and no, not here, not here, not here. We can take string memory name and string memory symbol here and then provide it here. So name, and does that solve the error? And let's see, Control Shift P, reload window. I guess it does, right? So we just need to mint those tokens. So let's say these number of tokens will be minted to this address at once. And now let's write this down, write everything down here. Parse error, where is the parse error? There is no parse error here. Oh, there is a parse error here somewhere. Oh, decimals. Okay, that's cool. Yeah, I guess it is. Yeah, no problem selected. And now let's make our some getter functions. We have a mint function which prints more money. There is a burn function which reduces the money, and then there is get balance for now. Okay, let's keep it at that. And then there is a function get info. Info. Yeah, okay, cool. We can return the name, symbol, and total supply. Okay, sorry, that's okay. Now let's deploy this, and what we will do is we will deploy this to Sepolia. Now, what is Sepolia? Sepolia is a testnet for Ethereum where the tokens have no value. Like we used to boot up Anvil, and Anvil used to give us these addresses. Similarly, Sepolia also has it. Sepolia is just a type of testnet. So what do we need for Sepolia? We need the same specs. We need an RPC URL and we need a private key. Okay, we can directly deploy it on Anvil also and then interact with it. That's okay, but we have a better way of doing it here. So you go to this infura.ai and you sign up there and you get your API key, and then you configure your API key to be able to, let's go here, and the endpoints that you need. So I need the Sepolia endpoint, so I'll go to Ethereum and I'll tick on Sepolia and you'll get your private key. So let me just set up those private keys and a private key for the wallet that I'll be using to deploy it. That wallet is here. This is the wallet which has some Sepolia ETH. If you want some Sepolia ETH, the best place to go is Sepolia Faucet, Ethereum Sepolia Faucet from Google. This is the Cloud Google Web3 platform. You can get 0.05 ETH for each day, so it will be more than enough for your deployment to be covered. So I'll just pause this and I'll get back in a second. So I have set up my private keys and RPC URL. Now let's call the forge create command. Forge create. Let me load the stored env first. And now we need to provide two things here. So there is a name and there is a symbol that we need to provide. Okay, so we will use something called forge create. Let's go for help, and we will use something called constructor args here. What is constructor arg? Constructor args are the arguments that you provide while you are deploying the contract so that the constructor is fulfilled from them. And this is the bad documentation. I have a good documentation here. So constructor args must be positioned as the last of command since it take multiple values. You can specify constructor arguments. Alternatively, you can specify a file containing space separated constructor arguments with constructor args path. Okay, so that's what we can do here. Arguments after the path, and we will comma separate them, I guess. Yeah, we'll see if those work or not. Okay, now let's go for forge create src token.sol token rpc url private key private key, and then we need the broadcast flag, and now we need to specify the constructor args. Okay, now the first constructor arg is my token, and the second constructor arg is what will it be, mtk, let's say mtk. And the compiler is running successfully, and I hope we get an address so that we can interact with it. I already know what address it will be, but if this was on Anvil, which is deterministic, we could find out what the address exactly it will be deployed to. So you can go to deploy to, and let's store it in .env. Let me just comment it here. I don't want you to see my private keys. So this is the address that we are going to interact to. Let's call this getinfo function. Send this address, and we'll write getinfo. Okay, and the return type would be memory, oh sorry, string comma u into 56, and we go for rpc url. Oh, I think we should need to go for cast call. We need to go for cast call, as this is just a getter function. Yes, so my token, mtk, and boom, we have everything that we need. Right now, this token address can be loaded directly in your Metamask wallet. So let's just go to ChatGPT, and just a second, just open ChatGPT here, and we'll go there, and let's go and say my token is deployed here to ChatGPT here, and we will say my token is deployed at this address. Will give me on Sepolia, by the way, give me an index.html to interact with following functions, and we will just specify what the functions are in this call here. So this will just give us the spit out the index.html that we need, get info, outputs, whatever we need here, it will be present, and we'll okay, we are using a library called Web3.js, which we'll get into when we make a full end-to-end project with front end, back end, everything. It will be a live stream mostly. So this is what we have here, and let's go live, and this opens here. Let's take it here, and we connect wallet, use Metamask, and we sign here, connecting here, and let's get the token info. So we get my token symbol, whatever here. Okay, let's get this address and check the balance. So it has complete tokens here. Okay, so all of the tokens that are present are actually in this contract. Okay, now let's see let's see if we can mint some tokens to another address. It's not exactly transferring tokens, so we can actually import tokens, honestly, and we can import tokens like this. Okay, next, import, and let's refresh the list. Let's import token again. Yeah, mtk, it got directly filled, and we have this much amount of tokens. I'll go to my another wallet, I'll copy my address. Now let me explain the difference between sending some tokens and minting some tokens. Okay, now what are we sending? We are not sending Sepolia, we are sending mtk, and we are sending, let's say, 69 mtks, okay, to account 2. So let's confirm this transaction. This is your first, I guess, interaction with a real contract, like a wallet. So this is how transactions are done. Token, you successfully imported mtk. Let's import mtk again here. This, and next, we'd like to import these tokens. Now let me just see. Just import tokens again. This sometimes fails. We got the mtk, and we got the 69 mtks, right? Now we can send these back again, and whenever we go to activity, we'll be able to see it. Metamask takes a while to update this, but here we see MTK tokens which are deployed, and we have this here. Now let's mint some token to address. Okay. Oh yeah, one more thing. From this address, the MTK value has reduced. Okay. Can you see that? Yeah. Now let's mint some to the address. Okay. Let's mint 100 tokens to this address. And transaction request, confirm. And the token minting must have been successful. The pending. And once it goes through, we'll be able to see the tokens on the other side of the wallet minted successfully. And let's go back. Let's go to account 1. By the way, here the amount of tokens has not decreased, and yet we have more tokens here. Just refresh this activity, and when we put here, and let's just get the balance of this guy. Okay, this has 69,000,000. That's why did it happen? Because we need to take in count of how much decimals do this contract have. So yeah, pretty short video for today, but we have a front-end integration and first interaction with wallets and how they work in front end. We'll be able to make a full stack app from dApp. It's called dApp, decentralized app, from end to end, from start to end, and we'll be able to deploy contracts for it. And yes, do let me know if you need anything else. I'll put the faucet link, deployed code, and yeah, that's all we need, right? Okay, thank you for watching.